And we continue our presentations this week. And today we're going to talk about transitioning from business requirements and function specification to describing classes with their attributes and behaviors, or attributes and methods. And that's going to be our focus. What comes to in importance at this stage is that we'd like to not just describe classes, but also address the quality of classes and issues that may be related to the different aspects that could be generally described as quality. And quality of class specification obviously translates to the quality of software, because we can implement better application in less time and spend more time on the efficiency and manageability of our solution, as opposed to constantly stumble upon situations where we have to redo something because there was a missing attribute, or there was sort of incorrect set of methods to begin with, so that we have to redo this. Not that it doesn't happen, it actually happens all the time, but this should be more of a minor adjustment level of work, rather than major adjustment and major change all the time as we go through our stages or iterations of software development. So, generally speaking, on the topic of transition from requirements to classes. So what we would like to address today, and what we would like to make part of our conversation. Like I said, obviously at this point we imagine that we already have the functional requirements, which is a set of use cases. Of course, there are non-functional requirements, but at this stage, we would like to really closely examine the content of the use case descriptions. And use case descriptions, of course, translate to user experiences using the system. And we would like to transition to objects and to classes that describe these objects as blueprints, so that we can essentially begin writing the code. So this is critical. This is really critical to begin with in any of the system. Really, you should not be starting your implementation unless this is just experimentation that you're really not planning to rely on in the long term. But it's really critical that you understand which classes you would like to have and how you would like to organize them. All right, so the methodology associated with this transition has to be scalable and has to make provisions for structuring and prioritizing of requirements. We said that the use cases should be prioritized, and therefore their review impacts, if you will, an order in which we design our classes. And scalability means that any system should be scalable, right? We would like to basically not perhaps discover some surprising differences in user requirements when we say want to deploy our system in in international business, for instance, right? So we should not be locking ourselves only to a specific locality, for instance. We would like to have a broader view to make sure that we can provide enough functionality to cover situations like that. So from use cases to classes continuously. So the analysis of use cases leads to discovery of classes and relationship between those classes. Most of the relationships fall into the category of association and inheritance. So inheritance specifies further or deeper classification, whereas association, of course, simply ties things together because we think that these classes somehow interact or interoperate or contain themselves. The classes, of course, should be derived from the vocabulary, from language that we use in our business requirements. Then as we begin to formulate the classes, we start to test the analysis of these, combination of classes as we start working with testing our user-related use cases. So, for instance, today I was thinking about a specific, subject maybe that we can work with, and perhaps very typical here would be real estate management system, right? Something like that, where you have properties and property owners. So, for instance, we can throw in like property owner. I'm thinking that property owner could have participation in multiple use cases. So we have a property, whatever the property is that they can own, right? So we have the property. I can associate these two, but not just yet. Then we sort of like have to perhaps define in more clear terms what the property is, what kind of properties we can have. It could be buildings, it could be commercial buildings, it could be residential buildings, and so forth and so forth. So most likely, my expectation is that we should probably have different kinds of properties, which I'm not going to mention just yet. And of course, we can have different types of property owners, right? There could be organizations, government, private, or just individuals owning the property. So there could be some implications related to the hierarchy of these specific types. So perhaps this real estate management system could help me to demonstrate some of the aspects that we're going to discuss today. So, right, and so we would like to obviously pay attention to these relationships that we discover or make decisions about. So for now, yes, I will probably connect these two, right? So they're definitely related, the property owner and the property, right? Okay, so categories of objects and classes. So we begin to think about what we would like to model and what we would like to use in our system. Generally speaking, you can begin to categorize even the classes that you would like to create. Earlier this week we mentioned, for instance, utility classes. Utility classes aggregate or encapsulate the methods that are just static methods, which basically perhaps encapsulate some sort of processes or formulas or computations which only require parameters but never capture any state. So that state doesn't persist. For instance, we can just compute, we could have a method that solves an equation, mathematical equation, and finds a solution for a system of equations, for instance. That probably will just take, just a few matrix or array type of data and use the formulas to solve the equation, and that really doesn't have to retain any of that data. That just returns back an answer. So that would be a method that would be typically part of a utility class. In our case, it could be like some sort of mathematical engine within our system. However, many objects would like to, and like real objects that have to be instantiated by real classes, are essentially do encapsulate the state. And some of them, not just encapsulate the state at some point, but they also would like to survive a particular use case. For instance, if user logs into the system, then they specify their credentials, the system validates the credentials, and the system could create a session object for that specific user that is now part of that communication, between the user and the system. And that should definitely survive and persist outside of just login, so that then they can proceed to other use cases, use the menus and other parts of the user interface to basically enter different use cases. So an object such as user session is a good example where it's an entity, right? An entity, typically, the categorization of an entity is an object that has a state that could be somehow recorded so that it will persist. Perhaps you can use the database in memory or the database in your persistent storage, like file system or database, but that would be the categorization of the entity object. The entity object will have, again, the first take on the entity object that it can be saved, so that its state can be saved and restored. But we also want to model the behavior of that, right? So sometimes, for instance, you can have an object that represents database connection. A database connection could be restricted by the database server license that you have. For instance, you can buy a license for the database server, which allows only a certain number of connections. So therefore, there could be additional rules that that database connection object would have to follow. For instance, simply not to try to violate the license rules that you own. Right. So definitely, entity objects not just persist and not just represent, collection of data fields or data attributes. Additionally, they too have behavior which can be attached to them, and of course we have a combination of data attributes and methods, and of course constructors, which are also a type of methods that represent these types of objects. Okay, so then as I begin to think of entities here, let me just elaborate a little bit on my real estate management system environment. So perhaps, we said that property could be maybe like commercial building, right? It could be residential property, right? Residential, commercial. It could be something, I don't know, like farmhouse. It could be there could be different types. Warehouses and so forth. It depends, what your problem domain really does. So again, let me just maybe clean this up a little bit and put this on my diagram that I'm trying to work with right now on my whiteboard here, right? So these are the types of properties that I'm thinking I will have. With the property, there could be a couple more things which will be important for the properties. For instance, how do we deal with an address, right? There could be an address. But by the way, property could be just a land, right? There could be a land that may not be even on a street. Like somehow you have a piece of undeveloped land that doesn't have a mailing address, so the mail cannot be delivered to it. So in that case, perhaps besides the description of an address, you may also think about a parcel of land, right? So something that you would, land parcel, right? Land parcel, something like this. So the property could be associated with both of these, right? A parcel of land and the actual address. So sometimes you don't have the mailing address, or you may have already a name of the street in mind, but there is no physical address like that the mail can be delivered to. So anyway, these aspects sort of are here. So if this is my land and this is my address, those two, and this is my property over here, then again, just trying to highlight and just try to restrict the boundaries of my drawing so that I don't overwhelm my drawing with different kinds of, but just basically just a little bit of highlighting kind of helps, right? So I'm thinking what would be, I mean, the obvious attributes over here, you know, the street name, the town, the zip code, you know, all the state, all the typical attributes for an address. For the parcel of land, however, maybe I can think about data attributes such as its perhaps its GPS location, right? I really would like to be able to provide an ability to perhaps, you know, invoke Google Maps or MapWorks or some other application and be able to specify GPS location, which will bring up the map and then I can have an area of it described here, and I can have additional attributes. For instance, such as, you know, environmental parameters. Is it wooded? Is it flat? Is it graded? Is it wetland? And so forth, right? So there could be, you know, those specific land-specific set of attributes, right? So I just kind of elaborated on these two to give you an example that very likely, that the parcel of land and the address are entity objects, right? Are these two objects that are basically connect with property in association with the property, but these two are examples, in my mind, are good examples of entity object which will persist in somewhere in the database, very likely. So these would be the examples of the entity objects, and therefore there will be classes describing them, right? So the next thing, an interface object type would model the information and behavior dependent on the interface to the system, right? So again, in some way, since there is so much hierarchy to different types of properties, and also in association here, the property class here has maybe some traces of an interface object, right? Because very likely it will specify what property can do in its attributes, whereas specific types of property such as land, residential, commercial, farmhouse, you know, colonial, whatever, multifamily, and so forth. Those would be, of course, implementation of that specific property, but most likely property will provide an interface to all kinds of types of properties I can have in a system. So the property would be an example of an interface object that model the information and behavior dependent on the interface to the system. Control objects, you know, it's often, actually let me record this segment before we continue because we've been doing it for a while.